Okay, welcome y'all to the first video of 2.1. Actually, first video of Unit 2. This is going to be 2.1 relations, and also kind of put in relations and functions. Alright, so basically we're starting, and we're also going to be talking a lot about domain and range. So let's talk about what relations and what functions are, and then what domain and range are. So basically what a relation is, it's a set of points, or more specifically, you just call them ordered pairs. Relation is a set of points. Now, when you move, so that's basically, so again, like, this right here, that's a relation, this down here, like, those are both relations, so just sets of points. Now, a function is a specific relation between x and y, so x and y, in which every x value corresponds to, and I'm going to capitalize this, exactly one y value. And basically what that means is that your x values do not repeat. Alright, and again, we'll kind of talk about what that looks like down here. Now, going up to domain and range, domain is the set of all the inputs, range is a set of outputs. And generally speaking, when we're talking about domain and inputs, we're thinking of x values. And range is the same thing, we're thinking of y values. So basically what we're doing with domain and range is we're listing out all the possible, or basically all of the inputs that I can have for this relation or this function. And then the range is the set of all outputs or y values, or all the possible outputs or y values that I could possibly have. Alright, so if we look down here at these first couple examples here, so this first example, we want to know, is it a function, and then we're finding the domain and range. So what I'm looking for here is, look at these x values. So I got 3, -1, 2, -2, and 0. Do you see any x values there that repeat? Your answer for this one should be no. So there are no x values that repeat, which means that it actually is a function. Yes. If I quickly move over to the second example here, if I'm looking at my x values, 0, 3, 0, I'm going to stop right there. I have repeating x values, which means that it is not a function. So if you repeat x values, that means that it is not a function. No repeats means it is a function. Again, that's what I'm looking for. Now the domain, as I said up here, it's my x values. I'm just going to list out my x values. It's going to be 3, -1, 2, -2, and 0. You can list that out in order. You don't have to. You could also, or just list it out any other way, but just make sure you get all those values there. And then the range is basically the same thing, but instead of listing your x values, you're going to be listing your y values. So for this one, 2, 0, -1, 1, and 3. So 2, 0, -1, 1, and 3. And the same thing for over here. My domain is going to be my x value, so 0, 3, 0, 4. I only have to list 0 out once, so it's going to be 0, 3, and then 4. And then my range, -2, -1, 2, and 2. So just -2, -1, and 2. One quick note here, you see that I have repeating y values. Honestly, that does not matter. The only reason that this is not a function is because of the repeating x values. I could have repeating y values all I want, but the second I have two x values that are the same, I'm done. It's not a function. Okay, we're moving on here. So we're basically representing relations in different ways. Set of ordered pairs like the original one, a table, a graph, a mapping diagram. So basically, we're just going to represent this, this relation kind of different ways here. So basically, usually for this mapping diagram, put the inputs there, put the outputs here. Inputs, those are my x values, so I'm just going to list out all my x values, 3, -1, 2, -2, and 0. My outputs are my y values, 2, 0, -1, 1, and 3. And then from 3, my input, I draw an arrow to my output, which is the 2. And I just kind of draw arrows over to my outputs. And it's kind of nice because, they're just kind of straight across from each other. And then with my graph here, Well, all you just do is just go ahead and graph those points. So 3, 2 is here. Negative 1, 0 goes negative 1, 0 right there. Go 2 over 2 down 1 right there. Negative 2 up 1 right there. And then 0, positive 3 right there. So again, a couple different ways that you could represent a function. Just making sure you're able to recognize all of those. Okay, so as you see, I kind of filled in these notes here for domain and range. You can kind of fill in the rest of the notes up top here. But basically, what we're using to find the domain and range on a graph is when we're finding the domain, because once again, in domain, we're thinking about x values, range. Actually, this right here should say range. And we're actually starting with y values. So when we're determining the domain, we start on the leftmost part of the graph and work your way to the right. And then when you're determining the range, it's basically the same idea, but instead of going from left to right, you go from bottom to top. And then basically any arrow on either of those sides means that you go on to infinity or as also negative infinity. Now, there's a lot of stuff to write here. If you need to pause the video real quick to write it all down, go ahead and do that. I am going to go and move on to these few examples here. So, first thing that we're going to do, start with the domain. I'm going to mark my graph here. I got left, right, and then bottom, top. All right, so I got bottom, top, left, and right. So I'm going to go to the leftmost point on my graph. So right over here, and as I see, it's an arrow. Now remember, what did I say that the arrows meant? Arrow on the left side, means that I'm going over to an infinity. But what infinity? Positive or negative? Remember, domain, I'm only worried about the x's here. And this arrow tells me that I'm going to continue going on that direction forever and up forever. And again, I'm only worried about the horizontal direction. As I continue going this way, negative 3, negative 4, negative 5, negative 6, I keep getting into the negative. So an arrow on the left point means that I'm going to go start at negative infinity. And again, always put a bracket, a parenthesis, around your infinity symbols. Always, always, always. And then move your way over to the rightmost point. Once again, that's an arrow. So, arrow tells me I'm going all the way over in that direction. And as I keep going, 1, 2, 3, 4, 5, 6, it keeps getting bigger and bigger and bigger until I get to positive infinity with a parenthesis there. Now the range, start on the bottommost point. Bottommost point is this point right here. And if you look, the y value, again, we're only dealing with y values here. My y value of that is going to be negative 3. And again, what I said about brackets and parentheses, this is a closed curve. There is no open circle. Sometimes you will legitimately see an open circle right there. But there are no open circles, no breaks in the curve, which means that we're going to have a bracket. Go with the comma, and then I work my way up. And if you look, well, there's two arrows that are pointing up. It doesn't matter which one you go with. They're both going up. And if they keep going up, and remember, you're looking at the y values. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It keeps getting bigger and bigger and bigger and bigger until you reach positive infinity. Okay? Alrighty. So moving on to this one here. Again, we're going to do the same thing. I got left, right, bottom, and top. Start on the leftmost point here. That's an arrow. Leftmost point is an arrow, which means that we're going to continue to go that direction forever. So again, automatic arrow on the left side means that I'm going to negative infinity because I look at my x values. I keep getting smaller, 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 and smaller until I get to negative infinity. Add the comma in, always put a parenthesis around my infinities. Go over to my rightmost point. And you might say, like, well, it's 2, that's where I stop there. But remember, arrows tell me that I keep going forever and ever and ever. I just can't graph forever and ever and ever. It's just not possible. So again, arrow here, even though it's at 2, tells me I'm going to keep going in this direction. And if I keep going in this direction, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, until I keep getting bigger and bigger until I get to positive infinity. close that, and then always put a parenthesis around that. Okay? Go my range. Again, bottommost point. I go to the lowest point I possibly can on the graph I'm given. Again, it's that arrow, which means that I'm going to keep going down. Even though it technically stops on my graph at -5, the arrow tells me that the graph continues to go down. So if I keep going down to -6, -7, so -5 to -6 to -7, keeps going until I go to -infinity. So the lowest part of my graph is at -infinity. And then as I work my way up to this positive point right here, it's going up forever and ever and ever because of the arrow right there. So again, even though it stops at 5 on my graph, it keeps going because of the arrow. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It keeps going until you get to positive infinity. And then again, you always put a parenthesis around the infinities. Never a bracket around the infinities. Alright, so I think this will be the last slide of the notes for this. Okay, so vertical line test. So basically, we're determining if a graph is a function now. So instead of, determining if a set of points are a function, we're looking at whether or not we have a graph being a function. So we do what's called a vertical line test. And basically what that is you take a vertical line, a line that goes straight up and down like these ones. Most of the times it's going to be your pencil. And you want to see how many times this curve passes through this vertical line. And in every single one of these instances, it only has one point of intersection. Passes through the line one time. If it only has one point of intersection, that means that it is indeed a function. Yes, it is a function. If I go over here and do my vertical line test, look at that. I got a point of intersection there and a point of intersection there. That's 2 points of intersection. If I have two or more points of intersection, it is not a function. Okay, so anything that's kind of like right on top of each other, like these and this, that is not a function. Alright, now let's go ahead and work out the domain and the range for these. So again, I'm still doing my same thing, starting on my left side, working to the right. Left side, this time I have a point. I don't have an arrow. So the leftmost point that I have, looking at my x value, is that -5. That's the leftmost point of my graph right there. If I go to the rightmost x value is going to be this +5. Because again, there's no arrow here. It's not going to keep going on forever and ever and ever. Now I got to determine brackets and parentheses. This time it's a little different because I got an open circle right here. This open circle means I put a parenthesis there. Whereas this +5 has a closed circle, I put a bracket down. Okay, I'm actually going to erase some stuff here. I'm going to erase these lines right in here. Now we go to the bottom point to the top point for the range. Bottom point is this point. The y value is -2, so I'm going to start at -2. It's a closed point, so we go with the bracket. We work our way up to the highest point. That's this point right here. The y value is going to be a +2. And once again, because I'm dealing with the open point there, it's going to be a parenthesis. Again, any open points means that I'm going to have parentheses. If I go over to this graph right here, domain, start on my left side, work my way right. On my left side, x value is going to be this -2. So I start with a -2. It's a closed curve. There's no open circles, so I'm going to start with the bracket. Work my way over to the rightmost point, which is going to be this. Again, it's just a point, no arrows at all. The x value of that is going to be a +4. So it's going to be -2 to +4, open circle, which means it's going to be parentheses. And this one's kind of nice because then when we do the range, bottom point to top point, bottom point's going to be -4, top point's going to be +3. They're both open circles, so we put parentheses.